Here's a great problem on neutralization reactions where we can see what volume of zero point 0.1 molar HCl solution is needed to neutralize 25 milliliters of 0.35 molar NaOH. I've got a strong acid and a strong base, and so those will neutralize. Remember the net ionic equation for this is H plus Cl minus will yield H2O. So that's a cool little thing to remember, and we'll come back to this in a second. So we start with our 25.0 milliliters of NaOH. I'm writing small because I'm going to need it. This is a great way to start whenever you start with your known volume and your known molarity, since those pair together. I'm going to use my molarity to help me along the way, and I'm going to convert milliliters. I'm going to put 1,000 milliliters on bottom to make 0.350 moles of NaOH. This is my molarity, and this is 1 liter, but I just put 1,000 just to save a box. Important thing to know is this is NaOH, so I need to convert NaOH to moles of OH minus, because which is still just a 1-to-1 ratio for this case, but it's not always the case, because if we had calcium hydroxide, the mole ratio would be different. This would be a 1-to-2 ratio, so it can throw your numbers off, so we're not doing that right now. Then I will move ahead, and since I screwed that up here, I came up. That's what that's supposed to be. Sorry. When this moles of OH will equal 1 mole of OH, it will be equal 1 mole of H. So just switch those over. H plus right here. And this is a 1-to-1 ratio too, because the coefficients for this are 1 and 1. And now I've got my moles of acid, and I'm going to save a box right here. You can, well, actually, no, I won't do that. Moles of H plus to moles of HCl, because remember, that won't always be a monoprotic acid, meaning it only have 1 proton, so that's a 1-to-1 ratio because there's 1 hydrogen and 1 HCl. And I have to continue over here to save space. And then, so I have moles, and then I'll put my molarity back in. This, I need moles of HCl on bottom. HCl on bottom, and then I'll put liters on top, because my moles is on bottom. So I'll put liters on top, liters of HCl. This is my molarity from up here. So 0.100 for liters. And then whenever I do everything out all the way around, you can get 8.75 times 10 to the minus 2 liters. Very nice. So to explain everything back again, this is my original volume. So this is my volume. This is my molarity. This is what I used for my molarity. This is my mole ratio for sodium hydroxide to my hydroxide ion, since the hydroxide ion ionizes. So that's just accounting for how many hydroxides are there. This one is from the net ionic equation, because the moles of acid equals the moles of base. Moles of base. Moles of acid equals moles of base. That is the essence of a neutralization reaction. Neutralization. Okay? That is the essence of a neutralization, is when the moles of acid equals the moles of base. Then I accounted for, since there's only one hydrogen in HCl, then I did that. And then I used my molarity again for my other one. This is essentially a titration, essentially, with a strong base and a strong acid. If you're saying to yourself, wow, there's a lot of boxes here, I don't know if I'm ever going to remember to write all those boxes. One little tip that you could do is that you could probably learn to leave these two boxes out, because you could learn to know that there's only one hydroxide here, and then there's one hydrogen here. So you could then insert your numbers into here. I just wrote it out long ways in the explanation to show you where that comes from. All right, have a great day.